When we know what is derivative, we can use it to find extrema, to find minima and maxima of a function. So first, what we mean by maximum. Maximum of a function occurs when in some argument the function value has some result, and in other points the results are not greater. If this is true only in some small neighborhood of the point, we are talking about local maximum. If this is true in the entire domain of definition, this is a global maximum. And if it is true that no other values are greater, then this is just maximum. And if the case is that in other points the results are not greater and not equal, that means lower than the result, then we talk about a strict maximum. And similarly, minimum is a point such that nothing is below. If the derivative in some interior point is positive and continuous, the function is increasing, no extremum. If the derivative is negative, the function is decreasing, no extremum. So a minimum or maximum can occur only in these three types of points. At the end point of an interval, an example might be a function arc sine of x. The domain of definition is the closed interval from -1 to 1. At 1, the function value is by half, and nothing is more, so this is a maximum. And at -1, the function value is minus by half, and nothing is lower, so this is the minimum. Another type of extremum may be in a point where the derivative does not exist. An example might be absolute value of x. The function absolute value of x has no derivative at 0, and it happens that at this point we have a minimum. Well, and the third case that we will be talking about in much more detail is when the derivative exists, but then it must be equal to 0. If we have a function f from R to R, that means just function of one single real argument, then we compute the derivative, denoted by f prime or ds dx, and we want this to be equal to 0. This is an equation. If we solve this equation, if we find the x values where the derivative vanishes, we find points that are possible candidates for the extreme. It is not yet true. This condition is necessary but not sufficient. Let me illustrate this by a simple function. For the function y is x squared, we have the derivative being 2x, and when we want this to be equal to 0, we get one point where the derivative vanishes. Such a point is called stationary point, and at this point the extremum may occur. For a function of one variable, we have two possibilities how to decide whether at a stationary point the maximum or minimum occurs or not. One way is to look at the sign of the derivative close to the stationary point. That means at 0, the derivative is 0. At positive x, the derivative is positive. At negative x, the derivative is negative. So the function changes from decreasing to increasing, and it has a minimum at this point. So this one way was to look at the sign in the neighboring points. Other possibility is to look at the sign of the second derivative. In this case, the second derivative is 2, which is positive, and this result, together with this one, is already a sufficient condition for the extremum to occur, and this tells us the function has minimum at this point. We will generalize this procedure for a function of more than one argument. And then we will use this second approach, looking at the second derivative and the sign of some expressions containing the second derivative.